The AI boom is no longer visible only in GPU orders or model launches. In the same news cycle, Intel reported 25% revenue growth while raising capital expenditure above $20 billion. The startup focused only on transformer inference reached a $10.3 billion valuation. Intel moved to explore glass substrate packaging with a Chinese manufacturer. NVIDIA embedded itself more deeply in a Korean research institution. A Chinese frontier model received day zero support in an open-source serving stack, and Washington activated a tariff authority it had never used before. These stories did not share a headline. Taken together, they point to a wider shift. In Asia's AI era, strategic control is moving into less visible layers. Finance, manufacturing, packaging, talent, software infrastructure, and regulatory compliance. Start with the macro anchor. Intel's second quarter 2026 results showed revenue of $16.1 billion, up 25% year-over-year, with the company attributing that improvement to AI compute demand and better execution. But the same quarter also brought a GAAP net loss of $2.16 per share, non-GAAP earnings of just 42 cents, and a full-year capital expenditure outlook raised above $20 billion. That is the central tension in the AI hardware cycle. Demand appears real, revenue is recovering, but the spending required to stay competitive remains severe. For Asia-focused observers, the key issue is not simply whether Intel can grow, it is whether a major Western chipmaker can maintain AI-era investment at this intensity, while Asia still holds important advantages in manufacturing depth and supply chain execution. Intel's results do not settle that question, but they frame it clearly. That financial pressure helps explain why capital is also moving toward more specialized bets lower in the stack. Etched, a startup building application-specific chips dedicated to transformer model inference, raised $300 million at a $10.3 billion valuation. The round was led by Sequoia Capital, with participation from Andreessen Horowitz, Jane Street, and SK Hynix. The investment thesis is straightforward. As production AI workloads scale, inference rather than training may become the larger cost center, and silicon designed only for transformer inference could be more efficient than general-purpose accelerators. The Asia-relevant point is not the headline valuation. It is SK Hynix's presence in the round. That does not confirm a supply agreement, a manufacturing tie-up, or any future commercial arrangement. But it does show that a major South Korean memory company wants direct exposure to alternative compute architectures instead of watching the inference specialization trend from the sidelines. If Etched represents a bet on new chip architecture, Intel's next move shows the frontier shifting to how chips are physically assembled. Intel and Lens Technologies signed a memorandum of understanding to explore advanced packaging built around glass substrates and a technique called through-glass via. As transistor scaling becomes harder and more expensive, packaging is becoming a competitive layer in its own right. It determines how multiple chips are connected, powered, and cooled within a module, and those choices increasingly affect performance. Glass substrates are being explored because they may offer better interconnect density and power efficiency for next-generation AI and data center hardware. What stands out here is not only the technology, but the pairing. Intel is a US company. Lens Technology is based in China. That makes the relationship worth watching, because packaging, unlike chip design alone, often depends on deep manufacturing cooperation across borders. Still, the limit is important. An MOU is an exploratory agreement, not a disclosed product rollout or a confirmed shift into production. It signals intent, not commitment. From physical integration, the picture broadens to national AI capability. NVIDIA has launched a joint AI research lab with KAIST in Seoul, described as a $300 million commitment over 5 years. The work is set to focus on agentic AI models, Korean language systems, and industry-specific applications, using NVIDIA's Nematron open models alongside local cloud infrastructure. This shows one form of sovereign AI now taking shape in Asia. National institutions are pursuing language-specific and industry-specific systems, but they are doing so on top of the tools and models of a global platform company. That creates a double-edged outcome. On one side, Korea gains dedicated funding, infrastructure, and a channel for domestic capability building. On the other, it also deepens reliance on NVIDIA-aligned platforms as the base layer for that capability. In this case, sovereign AI does not appear to mean separation from global platforms. It means trying to build controlled national capability through them. That same interdependence appears again at the software layer, but flowing in the opposite direction. Chinese model innovation is moving into globally used deployment infrastructure. VLLM, a widely used open-source inference-serving framework, announced preview support for Moonshot AI's Kimi K3, a mixture of experts model reported at 2.8 trillion parameters, with Kimi Delta attention and native vision support. VLLM said it provided day zero production-scale support, including engineering work related to the model's prefix caching behavior and hardware-level optimizations. Significance is not that deployment success has already been proven. It is the speed of integration. A frontier-scale Chinese model architecture is being absorbed into a globally shared serving stack almost as soon as it appears, rather than remaining isolated inside a separate tooling ecosystem. At the same time, the boundary of the claim matters. There are no adoption figures here, no benchmark comparisons, no cost data, and no usage statistics. What is confirmed is technical availability, not real-world deployment at scale. Beneath all 5 of those commercial and institutional layers sits a 6th: policy. The Trump administration announced the first-ever use of Section 338 of the Tariff Act of 1930, imposing additional duties on Canadian products alongside new aluminum and defense supply chain controls. Nothing in that action is specifically tied to Asia. There are no confirmed duty rates on Asian goods, no named Asian companies, and no regional implementation schedule in the material here. But the signal is still relevant. The importance lies less in geography than in precedent. A previously unused tariff authority is now active, and it is being deployed alongside supply chain controls linked to defense-related materials. For globally integrated manufacturers, including those tied to Asia's semiconductor and materials networks, that suggests trade policy risk may be becoming more instrument-driven and more security-linked, even when a particular action does not directly target their market. Taken together, these 6 developments form one strategic map rather than 6 unrelated stories. At the demand layer, Intel shows AI compute lifting revenue while forcing heavier capital spending. At the architecture layer, Etched shows investors funding inference-specific silicon, with SK Hynix signaling Asian interest in that direction. At the manufacturing layer, Intel and Lens technology show advanced packaging, becoming both a performance frontier and a point of cross-border dependence. At the institutional layer, NVIDIA and KAIST show sovereign AI ambitions being built through global platform participation, rather than outside it. At the software layer, VLLM support for Kimi K3 shows Chinese model innovation moving quickly into shared global deployment channels. At the policy layer, Section 338 shows governments widening the set of industrial and security-linked trade tools. None of this proves clean decoupling, and none of it proves a settled winner. What it does show is a layered system in which strategic leverage is distributed across hardware, software, capital, institutions, and regulation at the same time. For investors, the discipline is to follow that stack layer by layer, instead of reducing it to a single accelerator market. Watch whether Intel can convert AI-driven revenue into better GAAP economics, while still sustaining elevated capex. Watch whether Etched turns funding into production progress and customer deployment, rather than remaining a high-valuation concept. Watch whether the Intel-Lens relationship advances from exploratory agreement to qualification or product use. Watch whether the NVIDIA KAIST lab produces deployable Korean language or industry-specific systems, instead of only long-horizon research headlines. Watch whether Kimi K3's VLLM support leads to measurable adoption rather than staying a technical milestone. And watch whether Section 338 remains a one-off action or becomes a template for broader trade intervention. The commercial outcomes across several of these threads remain unproven. But the strategic message is already clear. In Asia's AI ecosystem, value and risk are increasingly concentrating in the parts of the stack that attract less attention. That is exactly where serious analysis now belongs.